Hi everyone, today we are introducing you to dilations, starting you off by talking about points, dilating points, and the concept of scale factor. As a reminder, you do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Be careful, make sure you don't fast forward too much that you end up missing out on something important. So let's start off with a review of dilation. Dilation is when you minimize or maximize the size of a figure based on the scale factor. So knowing that already, it's probably not going to be a rigid transformation, right? Because you're changing the size, you're not cloning it, you're not going to create congruent images. Scale factor is bolded because that's an important concept you're going to be using when you are performing dilations. The scale factor is going to tell you how much you are minimizing or maximizing. So it's like a scale. For a point, if you're just dilating a point, which we'll talk about today, you're just changing the location based on the scale factor because a point can't change size. It's just a point, a location. And a dilation, since it minimizes or maximizes, it's going to change not only the size, but it's going to change the location because that image is going to take up less space or more space, so the location is going to change. All right, so this is an example of an image, an object being dilated to a larger image. So notice how the location is going to change. It's going to get further away from your dilation point, and it's going to take up a lot of space, or less space. Some tips: if you can, use a ruler to be precise, especially if you're doing it by paper and pencil. On a computer, it's going to be a little different, but if you can, use a ruler. My tip is to multiply each coordinate pair by the scale factor that is more precise. We'll go over what that means later. The scale factor tells you what will happen, so be very careful and focus on that scale factor. If your scale factor is a number less than 1, so that's going to be a fraction that's less than 1, your image is going to be a smaller one compared to your object. So if a scale factor of a half means that the image will become half of the original size. A scale factor equaling exactly to 1 means it's going to stay exactly the same, because like anything times 1 gives you the same number. So it's just like multiplication. So multiplying is the key here. Scale factor larger than 1 means that your object's image is going to get bigger. So for example, if you have a scale factor of 2, it means that the image will become twice the original size. And it'll be as well twice as far away from your center. So there's two different things going on there. Be sure to jot this down before we move on to some examples. Okay, we are going to start with dilating points. So we are first going to read the directions. It says to plot the image of point B under a dilation about the origin 0, 0, this is the origin here, with a scale factor of 4. Okay, so there's a lot going on here. First, we have a scale factor of 4, so it means it's going to get further away from our origin. Our point is 1, 1. So like I said before, we're going to multiply. It's a scale factor of 4, so we're going to multiply both of those by 4. So you're going to end up with 4, 4. And it is going to be supposedly 4 times the distance away from the origin. So if we plot 4, 4 now, it'll end up right there. It should be 4 times the distance away from it. So again, we just took that order pair. This is 1 and 1, and we multiplied it by 4 for both of them. Okay? That's all dilating points is. It's multiplication. Your scale factor tells you how far away it is, or close it is, for dilating points. Okay, so let's practice how to dilate figures. This problem says to draw the image of triangle ABC under a dilation whose center is P and the scale factor is 3. So we know for sure, since the scale factor is 3, that it's going to be a bigger image. And real important here, the center is P. This is actually my second time doing this problem because the first time I did not read it correctly. I thought the center would be the origin. If it were the origin, then you would just write down the ordered pairs and you would just take those numbers, multiply by 3, and you would have your new ones. Okay? But the center is not the origin, so we're going to have to do something a little different for this one. It's not complicated, just different, okay? So again, since it's not the origin as the center, we can't just multiply. Here, I'm going to have to treat the P. Let me move this stuff over. I'm going to have to treat this as if it were the origin. Normally for the origin, you would write down the normal ordered pairs because it tells you the directions. The -2, 0 is basically saying I'm going from the origin left 2 and nothing up and down, right? For B, it would be -3, -3 because these are like directions. You're saying, okay, from the origin, it's to the left 3 and down 3. That's what those numbers mean. But now, since we don't have the origin as the center, you have to think of this as your center. So you're still giving directions. So from P, how do I get to A? Well, I go to the left 1, and then after I go to the left 1, I go 1, 2 up. Okay? For B, starting from P, I would go to the left 2, and then after going to the left 2, I go down 1. For C, I would just go to the right 2. Okay? So you're treating this as if it were the origin. So instead of writing down the ordered pairs, it'll be easier just to write the directions. Now that you have that, you can multiply it by 3. 1 times 3 is 3, 2 times 3 is 6, 2 times 3 is 6, 1 times 3 is 3, 2 times 3 is 6. So now for your green triangle, you're going to go left 3 from that P. 1, 2, 3. And then up 6. 1, 2, 3, 4, 5, 6. That's your A. For your B, you're going to go left 6, starting from your P. 1, 2, 3, 4, 5, 6. And then down 3. 1, 2, 3. So you're starting to see it come into shape. For your C, you're just going to go right 6, but that's starting from P. 1, 2, 3, 4, 5, 6. So that is your dilated image. So we're using P as the dilation point. If it were the origin as the dilation point, then it would be shifted over more. But this is your center here. Okay? So that's all that is. You are looking at your center and you are basically stretching it times 3 from that center. Okay, the next type of problems that you're going to need to go over is the dilation properties. We know now that dilation creates similar figures. So that means we said the angles are going to stay the same, but not the sides. They're going to be proportional. And by what proportion? The scale factor. Scale factor is constantly going to come back. That's going to tell us our proportion. And remember, we're making similar shapes now. Quadrilateral A prime, B prime, C prime, D prime is the result of dilating quadrilateral ABCD about point P by a scale factor of 2. Okay, so this is the old one. The new one dilated by a scale factor of 2, so it's going to become bigger. Very important. And it's by this center, so it's going to go out this way. It's going to be like over here or something. Okay? it's going out this way, according to the center. Okay, select all the correct statements. Let's see. Let's go ahead and, this was our sketch. So this is B prime, this is C prime. It's just a sketch, so it's not exactly accurate. And A prime. CD, that length, and C prime, D prime have the same length. True or false? Yeah, that's going to be a false because this one got bigger, so they're not going to have the same length. Next, AD and A prime, D prime. AD and A prime, D prime are on the same line. No, they're not going to be on the same line. This one's going to be moved over and it's going to be bigger. So also false. Maybe AB and AB prime would be on the same line, right? Because they're kind of touching each other when they move further away. They're still going to be on the same line, but not AD and A prime, D prime. They're like parallel. They're not even going in the same direction. Points B and B prime have the same coordinates. So they're saying that B and B prime are going to stay in that same spot. No, that doesn't seem to be true. Can't really draw anything there though. So that's an X right down there. Let's see, and none of the above. That looks like it's going to be our answer because we haven't had any of them that are true. Okay, so that's all these problems are asking you to do. You may have to draw yourself a little sketch and imagine it out, or you can take out a ruler and you can actually make an accurate sketch. But remember that not a lot of stuff is going to be the same between similar figures, just the angles, to be honest, because everything else is going to change. It's going to become a different shape. Let me know if you have any questions as you work on these, and I'll see you in class.